Ladies and gentlemen, the ceremony is about to begin. Would you please take your seat? And please be reminded to switch off your mobile phones or turn them into a silent mode during the event. Thank you. Before we start, please pay attention to our safety instruction for visitors.
歡迎嚟臨生產力局 Welcome to Hong Kong PC。喺活動開始之前，請大家留心以下重要嘅安全信息。Before the program starts, please pay attention to the following safety instructions. 請你留意緊急出口嘅位置。Please look for the emergency exit signs. 如果需要協助或者發生緊急事故，請通知本局嘅職員。Please let our staff know if you need help or there are any incidents. 如果蕩失路，請保持冷靜，然後打電話俾大樓管理處27885000，或者向本局職員求助。Keep calm if you lose your way. Call our Facility Management Office at 27885000 or find your staff for assistance. 遇有緊急嘅情況需要疏散，請保持冷靜，聽從本局職員嘅帶領同指示。In case of emergency evacuation, keep calm and follow our staff and their instructions. 請參考培訓場地裏面張貼嘅疏散路線圖。Evacuation route maps have been posted in each training facilities. 呢份安全須知，仲有其他詳細嘅安全資訊。如果有需要，歡迎各位來賓同本局職員聯絡。For additional information, please refer to a safety pamphlet and contact our staff if you need. 歡迎嚟臨生產力局 Welcome to Hong Kong PC。喺活動開始之
Ladies and gentlemen, good morning and welcome to the opening ceremony of 3D Printing Industry Specific Seminar, Toys, Game, and Premium Gift and Houseware. Organized by the Hong Kong 3D Printing Association, implemented by the Hong Kong Productivity Council, with the funding support from the SME Development Fund of the Trade and Industry Department of the Hong Kong SAR Government. I am Chuck Fong, Senior Consultant of Smart Manufacturing and Material Division in HKPC. Today, I will be your Master of Ceremony. First of all, I would like to invite Ms. Ami Sim, Chair Lady of the Hong Kong 3D Printing Association, to give a welcoming speech. Ms. Ami Sim, please.
Distinguished guests, ladies and gentlemen, good morning. This is my great pleasure to welcome you all to the second seminar of our 3D Printing Industry Specific Seminar series. Our focus today will be on toys, games, premium gift, and houseware industry. I wish to extend a warm welcome and friendly greeting to all local and overseas speakers and participants. On behalf of the Hong Kong 3D Printing Association, I would like to take this opportunity to thank the Trade and Industry Department of HKSAR Government, who generously supported our series of 3D printing industry specific seminars and workshops through the SME Development Fund. The program will be a key to support the local SME to cope with the world-leading country's development trend and grab the opportunities in 3D printing. As the first registered 3D Printing Association in Hong Kong, we take the pioneer role to promote the image and capabilities of 3D printing technology in Hong Kong, serving both local academia and industry. 3D printing technology is now undergoing a boom with the recent development in advanced printing methods and accessible materials. The cost is much more affordable and will soon become the mainstream technology in our daily life. It is important to make proactive efforts on offering a neutral platform to promote 3D printing technology and the innovative application to the local industry and community. Therefore, we have launched this project to support and enrich local SMEs' competitiveness in the international markets. 8 high-value industries with great potential in applying 3D printing in their operation are selected in this project, which including building and construction, food and beverages, toy, game, premium gift, houseware, jewelry, eyewear, fashion, and footwear. This seminar will provide comprehensive insights in the latest 3D printing technology and novel applications within various local and worldwide industry. The seminar speaker can come from different parts of the world, with strong industry background, as well as cutting-edge research from university, which will certainly stimulate many new ideas. Today's seminar will provide a valuable opportunity for the toys and houseware industry to keep abreast of the latest development of 3D printing. I wish all of you will be better placed after this seminar to seize on new business opportunity arising from this disruptive technology. Once again, I would like to thank the HKSAR government, HKPC, our honored speakers, and collaborating organization for making this event possible. I am confident this will be a very rewarding experience for all of us. Thank you very much.
Thank you, Mrs. Please remain on stage to present souvenirs to our speaker. First, we have Professor Johas, please. Johas is the Professor of Material Science and Engineering from Michigan Technology University. Johas, please remain on stage, wait for the group photo. And the next one is Mr. Fritz Hauer, creator of Lord Lesnar. And then we have Mr. Peter Donders, a roller artist and furniture designer from Belgium. And then we have our local speaker, Mr. Steve Steve was here. Okay, I call him later again. And another speaker from locals is Harris Yip. Harry. Last but not least, Mr. Stephen Ma, the founder and chief designer of Experience Design Inc. So Steve is still missing. We have the group photo first, and we can take another one when we come back. And please still remain on stage. We have one more pictures. And would the representative of the supporting organization who have joined us today to come up on stage to have a group photo. Mr. Ronald Fong, Hong Kong Electrical Appliances Industry Association. Mr. Ivan Ting, Hong Kong Toy Council. Mr. Dominic Tam, the Toys Manufacturer Association of Hong Kong. And Dr. William Poon. So everyone's here? And our committee member of Hong Kong Philippine Association, Mr. Ho, Simon, and also Peter have his son come to Hong Kong too. You can join to take the pictures. And me.
Thank you.
Many thanks to our official guests, speakers, and supporting organizations. And thank you all of you joining us this morning. Before the seminar begins, I would like to announce a switch in the speaker sequence today. Mr. Stephen Ma will give his presentation on 11:45 a.m. and followed by Mr. Howard Yip. After the lunch break, Peter Donders will be the first to give the presentation, followed by Steve. The seminar will now begin. I hope you all will enjoy today's event. May I now introduce our first speaker, Professor Johas, please. Johas is the Professor of Material Science and Engineering in Michigan Technology University. He is known for his work in open source hardware, web 3D printing, and the use of the device for high-value designs. He will share with us the ways of distributed manufacturing with 3D printing of toys, games, and premium skin. Johas, please.
Hi everyone. So before I officially begin, I want to introduce you to what your new customers might look like. So this is Bindi Small. She's not a model or an actress. She's not famous. She's just a person that likes to design her own things and wear them. And there's a couple things that you can pick up from that photo. First of all, the outfit that she's wearing, I think you can objectively see that it's pretty interesting, it's pretty cool. It's maybe even better than what you can commercially purchase right now for a Halloween costume. The second thing that makes this sort of amazing is that she was able to make that using only open source software. She used Blender, which is a software package that's usually used in the movie industry to make 3D animations, and she used that as a CAD package to make an outfit that's customized to her, not just fitting her actual proportions, but also kind of being fan art for a video game that she likes. She then used an open source 3D printer to manufacture it. So all across her entire tool chain, from the software that she used to do the design, to the software that's controlling the 3D printer, to the software that's on the computer running it, and the 3D printer itself, everything is using free and open source code. And she came out with something that's pretty amazing. The challenge I give to you today is, if this is your customer, so she's old, she's an adult at this point, but children are learning how to CAD in school now. And so they're going to be able to accomplish the same thing that Bindi did by the time, by let's say the 3rd grade, by the time they get a little bit of experience in school. And so those are the people that you have to consider who you're making toys or houseware gifts for. So as an outline for my talk, first I want to talk a little bit about why 3D printing is so expensive, why things have changed so much. And to do that, you have to understand a little bit about what open source hardware is and why that's driving 3D printer evolution right now. And then I'm going to talk about the potential for distributed manufacturing, where people actually manufacture at least some of their own products. And that usually when people talk about distributed manufacturing, they mean local shops that produce things for customers, or having small manufacturing facilities spread all over the place. And I'm not going to discuss that. I'm going to talk about the much more radical premise where people actually do the manufacturing in their own homes. I'll apply it a little bit to household items and then toys, and then finally we'll end with some trends and predictions, and I'll give you a solution to the problem of how do you sell things if everybody's making their own stuff. So first of all, 3D printers have been around since the 1980s at least, and you probably never heard of them, you probably never got to use them. I know I didn't get access to one until I was a professor deep into the 2000s, and there was one rapid prototyping system at my school. I know, this building, I think, housed some of the original rapid prototyping systems for all of Hong Kong when they originally came out. So they've been around for a long time, but now they're suddenly kind of flying off the shelves, and people are buying them. Basically, every engineering firm has them to do rapid prototyping of their next designs, no matter what the product is. Most schools have them, certainly at most universities and many high schools, maybe even most at this point. If you go to places like Finland, it's now quite common to have 3D printers in the public libraries. And so you have everyday citizens printing off things that are of interest to themselves. To understand why the price suddenly plunged so much, you have to understand this concept of open source hardware. You probably heard of open source software. Free and open source software, even if you don't use Linux on your computer at home, you use Linux every day if you use the web. All of the major internet companies, the Facebooks, the Amazons, the Googles, are all running Linux on the back end. And the reason they're doing it is beyond that the cost of the software is free. The free and open source software actually refers to freedom. It's the freedom to alter it, to look at the code, to change it, to sell it, to do basically anything that you want with it. However, there's a viral aspect to the licensing clause. And the viral aspect says that if you make a change to the software, you have to reshare it with the rest of the global community. And so because of that, rather than having one company, no matter how blessed they are with talent and smart people doing the code, you now have potentially thousands of companies, or thousands of individuals, millions of individuals all over the globe working to make software better. And because of that, it often ends up being significantly better. So if we think of Linux, which is sort of the poster child for free and open source software, it started in an apartment in Helsinki by a graduate student who wanted an operating system that could do what he wanted because the operating systems of the day couldn't. And now it's grown into this behemoth that's not only running all of the internet. If you look at, say, the supercomputers, like if you want to do high-performance computing, 96% of them are running Linux. And then, so it's essentially built up in the beginning by all amateurs and volunteers, and now there's major corporations that are constantly contributing to the code. And so it's made superior software. The other thing I want to point out about free and open source software is that it's not necessarily anti-business, and it doesn't mean that you can't make money off of it. The Red Hat logo on the bottom there, on the bottom left-hand side, is an American company. It has multiple billions of dollars a year in revenue, and their product is a version of Linux that right now everybody here can download and install on the servers of their own businesses for free. And you say, well, how do they make billions of dollars if they're giving away their primary product for free? In fact, it's not only that. If you wanted to, you could download it, put it on a DVD, and then go sell it on the street corner completely legally. What they're offering is the service to make sure that that software works the way that you want it to. And so if you're doing everything from banking to industrial manufacturing, it doesn't matter what it is. If you want the software to work, you pay them in order to make sure that it does what you want. Now, they have to provide excellent service because you can walk away from them at any time. Because the software is free and open source, you can bring it in-house and have your own IT staff support it. You can go to another company. And so because they know that they are competing not just with one or two other companies, they're competing with everybody, they have to really stay on their game and make sure they're providing you the best service. They do, and they make billions of dollars a year. And so that's giving away something as ephemeral as software. Now, if we take this idea of free and open source software and then start looking at how we could combine it to make visible objects or hardware, that's when something like this comes along. So the Arduino is originally an Italian project. It's an open source microcontroller. And what it means when you say free and open source hardware is that the schematics, the code to make it, the wiring diagrams, the method of manufacturing, the bill of materials, everything is provided free. It's all available to everybody. If you want to start making Arduinos right now, and many companies actually in China do, you could do that and start selling them. It's totally legal and completely okay. What the Arduino did is take the idea of a microcontroller and democratize it so anyone can use it. When I went through school, to do something like controlling a robot hand was the purview of NASA. You basically needed a PhD in order to write the code to be able to do something like that. Today, I can teach a third grader how to control a robot hand using an Arduino in like half an hour. It's not challenging anymore, and it's not because I'm a genius or the third grader's a genius. It's because hundreds of people, thousands of people all over the world have been hacking on these Arduinos, And so they've developed a code base to make doing anything that you can think of very easy. So an Arduino is basically an actuator, so you can measure something from the environment, say a temperature, and then control something like, say, turning on a light. And so if the temperature gets up to 50 degrees, it turns on a light. Doing something like that in the olden days with the old-style microcontrollers basically meant that you had to code in machine language, which very few people can do. This makes it easy. It's almost like writing a story. Once you understand the syntax, anyone can do it. So there have been thousands and thousands of products using Arduinos to automate things, from art projects to toys. And of the most impressive of the automation projects is the development of the RepRap. So the RepRap stands for Self-Replicating Rapid Prototyper. And so it's a 3D printer whose purpose, the purpose of the design is to be able to 3D print its own parts. Adrian Boyer there on the left is a professor, was a professor in Britain. And what he did is he made a printer that was meant to make its own parts. And rather than patent the invention, he quickly realized that it would be very difficult to sell more than one of these or be able to protect the intellectual property if, as soon as you sold one, other people can make as many of them as they like. The parts for that printer were printed on a standard commercial rapid prototyping system for Stratasys. And the timing of it matters quite a bit, because the Stratasys patent for fused filament fabrication, where you're extruding filament through a heated nozzle, had just expired. And so what this meant is that he was able to put the RepRap into the open source ecosystem. Made one in-house. Now there's tens of thousands of these, at least, all over the globe. They now dominate the 3D printing space for desktop 3D printers. And it all started from one professor sharing the idea with everybody else. So how do they work? Probably most of you are at least a little bit familiar with 3D printers, but this particular kind that I'm talking about is the low end. This is the bottom rung, the entry-level 3D printer that is affordable to little kids. It takes a long string of spaghetti-like plastic, extrudes it out of a nozzle by melting it, traces out a two-dimensional shape, moves up a fraction of a millimeter, and then builds up eventually an entire three-dimensional object. Everything about this system, after you built one, is extremely simple, and all of the code base to run it is all free and open source, and it's all based off of that Arduino as sort of the brains of the operating system. So if you think about traditionally how we've made products in every technology, you tended to want to patent things in order to be able to lock down the intellectual property so you can get funding from banks so that you can grow your business. And that method does work. And it brought us to the point that we are today in 3D printing. Stratasys was the first company to get a patent on this fused deposition modeling technique where you're melting a long string of filament. And they did evolve. Like if you look at the early Stratasys printers, they were atrociously terrible. You wouldn't even barely consider using it for rapid prototyping. And by the end of that 20-year patent, their printers were pretty good. They're fairly reliable. They make good, nice products. You even think about selling the print rather than just using it as an actual prototyper. But their lowest end printer at the time that the patent expired was $20,000, and it could print in ABS plastic, which is a common plastic. But you couldn't use, anybody's ABS. You had to use theirs. So you were stuck with proprietary filament on a proprietary tool that you didn't really understand how it worked. You didn't have access to their code base, the software, and it cost $20,000. And so there was no way $20,000 printer is going in everybody's home. It's simply it was stuck in this idea that you only use it for prototyping. And if we look at the open source version, you can't use the term FDM because that's trademarked. You have to use FFF or fused filament fabrication. There are literally weekly improvements, and this isn't hyperbole. There are thousands of people hacking on these devices all over the world, and every time somebody makes an improvement, they send it back up onto the web, and then all of us, including myself and my own students, can pick and choose the properties that we like the best and incorporate it into our own printers. I run a 3D printing class that has 50 students in it that kind of battle to get into it every year, that build their own printers. And the final assignment is to make an improvement on the printer. And so every year there's this flush of new innovative ideas coming out of Michigan. Some of them are good, and they're taken by not just other people messing around with these kind of like on a hobby basis or an educational basis, but by the companies selling these printers on the market. And so what that's done is it's pushed the cost of a 3D printer well under $1,000. There's now dozens of companies that sell these printers between $400 and say $2,000 or $3,000. The feedstock is openly and readily available. You can get plastic filament, all over the place. All different kinds of companies can make it. You can purchase an extruder for under $1,000 and start making it for yourself. And you can even go all the way down to waste plastic. So you're not even limited to kind of virgin high-quality polymers. You can use any plastic. So if we look at this kind of first version, it's boxy and clunky, has a lot of parts. It's difficult to put together. And our research group sort of got started at the beginning of this. I used 2 students an entire summer to build the first one for my lab. And it was very frustrating, very difficult to work with. It broke as soon as we got it functioning. It was nowhere near ready for showtime, sort of in the mass market. And then the second version, you can already see it starting to evolve. There's less parts associated with it. It's still using the same kind of basic core Arduino architecture with a shield on top of it and motor controllers. But there's less parts. It takes less time to build. In this case, Brennan here was able to build it in a semester and get it working. It was more reliable, made better, faster prints. It cost less. Everything about it was superior. And it's not, again, because my group was any good at this. It's because of people's ideas all over the world sharing it. By the time we were on version 3, I actually felt that we could share this with the actual public. So this cost less than $600 in parts. Someone that knows nothing can learn how to build one in 24 hours, and 2 people that actually know what they're doing can put one together in 5 hours. It's using an Arduino, except you can see that the board's changed. There's now specialty board manufacturers that are making Arduino-coded boards specifically for 3D printing, which has dropped the cost. And so this is maybe beginning to give you a hint of where markets might exist that didn't exist before. Before the RepRap project, there was no market for an Arduino-based rapid prototyping 3D printer controller. There was just no such thing. Now we're building these 3D printers, and you can see these look totally different. A group in Germany took a pick-and-place robot, like in the electronics industry, and put a print head on the end of it, and it turned out to be an excellent printer. And so our group has shifted to this type of 3D printer. It again uses far less parts, it's less costly, easier to build. Someone that knows nothing can put one of these together in 8 hours if they follow our instructions. So this has gone from being a semester project or like something worthy of a class to something where I give the kids the parts on Friday and say on Monday come back and have it functioning so that we can actually use this to do something. It prints faster, less parts, less cost, everything about it's superior. And if you look at these ones, all the black and yellow pieces were again printed on its own printer. Actually, the gray piece as well, the end effector as well. The costs of these kits to build 3D printers has gone crazy. On Amazon, there's many 3D printers that you can purchase for under $200. This one just hit the market, it's $99. I built this with my own children, and it's not the best 3D printer out there. It actually reminds me of the old days when you had to self-bed level and you kind of actually had to tinker with it to get it to work right. But I was actually in one of the shopping centers yesterday, and there was a bunch of 3D printed figurines, and I swear to you, there's no doubt I could print those figurines on this printer. No doubt at all. They're nice little small, like little squirrels and things. So this printer is not the best. It is not something that you would want to use in industry, but it is something that can maybe get people's appetite whet for 3D printing at home. So this idea of people 3D printing at home, there's been an enormous amount of hype about this. And I will be the first to tell you that when the hype originally started, the 3D printers that were on the market were terrible. And many people got frustrated with them. So they would buy a 3D printer, they'd expect it to print like a 2D printer, you just hit print and go. And they did not operate like that at all. You had to be very good with it. You had to be technically competent, you had to fidget with it, you had to get it to the point that it was just right, and then hope that nothing changed, like, say, the humidity. In Michigan, where I'm from, humidity goes up and down. So in the winter, printing is awesome. Summer comes, and it's like outside right now, you can't get anything to print right because the plastic is sucking in moisture and expanding and not printing properly, and so your prints don't turn. So what we did to probe this idea, we felt that the RepRaps that we were building were actually pretty robust, that you still needed some technical competence to put it together, but once it was going, there was a chance. And so we made a random selection, completely unscientific, of 20 objects. And the way that we did it is I asked my students, what do you want? We're going to do this printing thing, and you can have whatever we print afterwards. So we got this totally weird mixture of iPhone cases and toys and stuff for the house. And I wanted to make it realistic. So the average consumer, at least in the United States, is not CAD proficient. They have no chance at all to barely turn a computer on. And so I made it so that we only considered designs that were already freely available, completely legal, open source designs that were on the web, and that would fit on a rep-wrap print bed and be able to be printed out of common plastic and used. So something like a spatula, although yes, you can 3D print one out of ABS, you would never use it because it would melt, when you're cooking your eggs. And so we did a straight cost comparison where we compared the cost of the plastic and electricity, which is the cost of manufacturing essentially in your own 3D printer, to commercial costs that were available on the web, taking a high and low case. Now, on the low case, what that means is the lowest possible cost we can find on the web from a reputable manufacturer. So this isn't something like on eBay that fell off the back of the truck. This is something that you could get from Google Software or Amazon. And then the high-end case is the same product but has something special on it. Like maybe there's some sort of customization, you can put your name on it, or something like getting closer to an equivalent. So it's just not the cheapest version of the object, it's something that looks about the same. So here's some examples of some of the random objects that we printed and the results. And so on a $600 rep wrap, printing just 20 random objects, you could offset the cost between $300 and $2,000. $300 for that low-end, cheapest thing that you could find on the internet, $2,000 for the high-end. And so what that means is if you print out 40 things, you've essentially paid for the printer just from doing that. And what this meant is from a consumer's perspective, microeconomics, the 3D printer is a solid investment already. You assume that you print basically 25 hours of printing. The civil payback time for rep wrap is 4 months to 2 years, depending on whether the high or low case that you're talking about. And this provides a return on investment for the consumer between 200% and 40%. That's pretty good. So if you think about comparing that to the stock market returns for the average investor over time, it's around 7%, and that 7% is before taxes. Here, these are after taxes. There's no tax on something that you make for yourself at home. So this paper came out in 2013, and we actually got a lot of flack from it. And the flack that we were taking is that, yes, the data is real, but it's not realistic because we're all engineers. The people that go to my university are already extremely technically savvy, and then I'm taking the most technically savvy and putting them on a 3D printing project, and lo and behold, they can make something. The average consumer is never, according to the internet, going to build their own printer and play around with it. And so this meant that we had to take a closer look. And looking back through the data, the thing that struck me the most was the shower curtain rings, which is, of all the 3D printing articles, the very least impressive. There is absolutely no reason that mass-manufactured injection molded shower curtain rings should ever cost more than rep-wrap 3D printed shower curtain rings, because I know that the cost of filament that you can buy on the market from Amazon is marked up at least by a factor of 5, at least. So there's no reason that should happen. Yet when you looked at the data, we could print a package of 12 shower curtain rings to keep your shower curtains off for about $20. Purchase was $2.99, and the one that I showed here is kind of more indicative of what you buy on Amazon. Costs $9.99. Now, when you 3D print your shower curtain rings, you can print in any color that you want. You can make a more complicated design. You can have a lower infill so that it's lighter, so you can actually make a shower curtain ring that has less material in it than one that you would purchase, which makes it better for the environment and costs less, at least from the beginning. And there's no additional cost for the complexity of the design. Now, does anybody recognize the ring at the bottom? So that's from the History Channel. They have this very cool show called Vikings. It's one of my family's favorites, where it's sort of historical, following the life of these kind of Vikings as they, throughout the ages, as they raid England and everything. And to promote the program, they put several 3D printable objects up available on the web for free. So that ring down there at the bottom is the bracelet for one of the main characters that he gets when he becomes a man. Looks pretty cool. Makes an excellent 3D print, and all the curtains in my house have that as the curtain ring. It is neat. It has some higher value for my family, and I was able to make it for less than I could purchase an equivalent ring on the market, and it just didn't exist. So this brings the idea that it's possible, at least in theory, that you could print dollar store junk for less than you could buy it at the dollar store, and less than you could purchase it on Amazon. And when you think about these 3D printers, it's possible that when you're talking about doing the manufacturing, you're not actually active at all. You really are just hitting print and walking away from the machine, or you're sitting up and watching it go as a form of entertainment while you're drinking your coffee. to give you a feel for how it's just not the 3D printers evolving, but also the open source designs, I give you the example of a safety razor. Now, most people don't use safety razors because you have to put in a significant investment up front, usually $20 to $80, to buy a nice, good metal-handled safety razor. A package of 10 blades, bought off of Amazon again, cost $5 or about 28 cents a blades. Most people would use like a Gillette cartridge, disposable. And so your cost of ownership, shaving your face, normal rate of beard growth, is about $300 a year. The picture there on the left is a really crummy safety razor that I designed. And if you look closely at it, you can see it's held together with an M3 nut and bolt that was left over from some of the rep wrap belts that we did. And if you look really closely at my face there, you can see half of it's shaven and half of it's not. And that's how you test yourself as an engineer. You know, are my CAD skills good enough? Did I get the angle of that blade right that I'm going to put it on my own neck? And it worked. It wasn't pretty. It wasn't something you'd ever give your dad for Father's Day. But it was functional. 3 months later, somebody made one that actually looks like a product that you might consider buying. And they took the original idea I had and then built off of it. And that was shared again. And so now let's say that you're, I don't know, really into Vikings, you could turn that into a Viking safety razor for your parents, or for your dad, or for your kid that is becoming of age and starting to shave. And if you look at the economics of it from an individual's perspective, shaving with disposable blades off of a razor that you printed can save you $19,000 over your lifetime, assuming that you start shaving when you get puberty and when you die from time. So that's a huge potential savings from a single product. And you can see where the money is in that product. It's in the selling of the thing that is not 3D printable now. Now, distributed manufacturing is being held up for all different kinds of reasons. Like, people aren't aware that it's possible yet. But the biggest one is, of course, economics. And in that case, it's hamstrung by the cost of materials. So if you go onto the web and you look for buying ABS pellets, which is what you turn a filament out of, it costs like $1 to maybe up to $5 per kilogram. If you look at the cheapest filament that you can find, that's up in the $20 to $25 per kilogram range. And some of the higher end, more famous 3D printing manufacturers are selling spools of filament for about $50 a kilogram. And so when you're buying plastic at 5 to 10 times more expensive than what the real manufacturers, the traditional manufacturers might afford, it's very hard to make an economic case for simple objects. But there's no reason in the world filament has to be that expensive. And so we've seen filament costs come down by about a factor of 2 in the last couple of years, and I would predict that we're going to see, as more and more competition enters the market, those prices come down even further. And one area that is absolutely going to present some competition is possibly the consumers themselves. And so this, if we're going to do distributed manufacturing, it's also possible we could have distributed recycling. So in the US, we have these giant gallon things that we serve milk in. If you take your milk jug, clean it off, cut it up into pieces with a scissor, throw it through a crosscut shredder that you would like normally shred, say, beans or something with, it can be fed into this little gizmo there on the right, and that's one of the first ones. So it's a little ugly. But what it does is it's a motor and a hot tube. And so the motor drives an auger which pushes shredded plastic into the hot tube and melts it, extrudes it through an orifice that's, say, 3 millimeters or 2.85 millimeters big that makes filament. You then put the filament in the 3D printer and start to print things. Now, my group has done a lot of work in this area, and so ABS is easy. You can make good, high-quality ABS filament that prints just as good as the original. PLA is the most common 3D printing filament. That, again, is very easy. And this particular example is with HDPE, which is the second most common plastic waste material. And it is challenging. You have to do some special things to get your printer to work with it, but it is certainly possible. And actually, on the way here, I got an email from Tech for Trade, which is a nonprofit in Britain that is also doing a lot of work in this area of recycled filament. And they have finally gotten a reproducible open source method to get PET, which is the most common plastic. Normally when you buy PET-like plastic on the market for 3D printing, it's PETG, it's not straight PET. But they've got PET to work. Now, our group, I guarantee you, will test that. If that works, it is going to become very feasible for people to start to buy something like this recyclable. There's many commercialized versions in order to start extruding their own filament from their own waste. And now, that changes the economics completely. So let's consider a kilogram of HDPE. takes about 20 milk jugs to make that, and it costs about 10 cents in electricity to do the extrusion and the shredding. And it turns out that the shredding, mechanical shredding, some of you probably know, uses hardly any energy to begin with. Kilogram of commercial filament, I said, is in that $25 to $50 range. And so let's take the example of an orange juicer. The least expensive commercial equivalent, where you have a juicer and put it on top of a mason jar, is $7. The good ones are up in the 20s or 25. If you make it from commercial PLA, which is already marked up, it's at $2.76. If you make it out of HDPE, it costs 4 cents. And so now you've got a household item that is almost throwaway. Like you could make a couple things of orange juice, maybe it's too much trouble to run it through the dishwasher, you just get rid of it. If we take it into the toy area, those toys on the left there are versions of a block set for kids in Switzerland. And it's apparently for very rich kids in Switzerland. A packet of 16 blocks costs 160 bucks, which, at least for my family, is pretty expensive for a couple of blocks. But if you make it out of recycled HDPE, now it's 64 cents. And so what that means is that not only the super rich kids, Swiss kids, get to play with the cool blocks, now basically every kid, no matter where they live, would have access to it. Now, everything I'm saying so far is dependent upon the idea that you have technically savvy consumers. And that might be true in places like Hong Kong, but not so much in the United States. Some of us are, but certainly not all of us. And what I'm showing here is a workshop. We've been running workshops for several years now during the summer for high school teachers, where they come in and build a 3D printer. And from the workshops, we've learned a couple things. First of all, the very first workshop that we did, we wanted to bring teams of teachers in so that they'd have some support when they went back to their school. So if one person sort of heard and understood it, they could help the other person out. And so we had teams of 2 teachers building one printer, sent them back to the school. Printers were all working great. We were so happy. We thought this was this great success. And then we found out that all we'd done is cause an enormous social problem where the teachers were fighting over who got to use the printer. And so ever since then, we've gone to one teacher, one printer. These teachers are all self-selected, so they're the ones that are doing the extra effort to learn something new in the summers, that are signing up for these courses, and so they're not even representative of the average teacher. They're the good ones. They're the science teacher. You want teachers, your kids' science. But these printers are now all over the place, so I can speak at least for kind of Michigan. There are hundreds and hundreds of these, many, many high schools, maybe not most, but a large fraction of high schools within Michigan now have printers or descendants of these printers, because often once one of them gets into school, one of the very first things they start doing is printing out the next one so that other classes can take advantage of it. But that still doesn't mean that the average consumer is going to ever feel comfortable with that, or say recycling. We have a hard enough time recycling when you only have to put it in a waste bin and take it out to the curb, let alone grind it up and clean it and turn it into something yourself. However, with the recycling on the curb, you're not getting anything in return from that. You're just feeling slightly better about yourself or the environment. When you're recycling yourself, you're actually displacing a possible purchase of, say, filament. And anybody that has a 3D printer and uses it any length of time knows you burn through filament pretty fast. I mentioned that you could commercialize open source 3D printers, and that absolutely is what has happened. Maker Magazine is a magazine for the maker culture in the United States, I guess globally, about the English-speaking maker culture. And every year they run a 3D printing shootout where they take all the desktop from the consumer-grade 3D printers, test them out, printing out something like an astronaut or a pirate, and then rate them. The last couple of years, the top spots have always gone to the open source 3D printing manufacturers. Now, all the printers that I'm showing here are open source. Some are Delta style, the others are Cartesian based. The one on the left is the Taz, the one on the right is the Prusa. Those two, the top left and the top right, are the 2 printers that sort of battle it out for first and second every year for the highest quality desktop printer. The Taz's were made by engineers, basically for engineers. And so Ford, for example, likes having rapid prototyping systems at the desks of their engineers. And that was what market they were going after. Prusa is one of the original team members on the RepRap project. And so it's in Europe, and it's going to be the most pure of the original printers. That printer costs $800 in kit form. and the Taz is $2,500. And so possibly not still at the price point where every single home is going to have one, but certainly the upper middle class and the middle class would have access to them. And then it just isn't necessarily small stuff. In the lower right-hand corner, this is Re3D, which is a 3D printing company that's a spin-off from a bunch of NASA engineers. And so they're all like quasi-retired and now building these giant 3D printers. So that's a meter cubed, and you can make a pretty nice size print with it. And certainly if you're thinking about bigger things, that is an open source alternative that again is much lower cost than you would normally consider for a production piece of equipment. What about the plug and play printers? Can we make a printer that's easy enough to use that basically your average consumer could? And I'm fairly happy to report that that's already happening. So this is the Lulzbot Mini. It sells for $1,250. Making this thing work involves taking it out of the box, plugging it in, and plugging a USB to your computer, and you're basically ready to go. It self-bed levels, it checks the location of the printer head right in the beginning, it cleans the nozzle, it basically does everything that you used to have to do manually has now been automated, and it really is to the point where you can download a decent design off the web in their software, which is again pretty open source, click print, and it will work. And so you can start to think about people actually using this. And so what we did is we repeated the same study we did before, now with a more expensive printer. And there's a couple interesting things I did about this one. And rather than pick one of my engineers that have been working on 3D printing for years, I took a novice. I took a freshman that didn't know anything and had never used a 3D printer before, only seen some when she was doing an internship at a company. Didn't work on it at all. And I said, pick random things. And again, we did this sort of assumption that you print one thing per week for a year. Overall, the operating cost for a printer, printing at that rate, is about $40 per year for commercial filament. And then this shows, doing that same low and high cost comparison to commercial items, what the savings would be. And so a $1,200 printer doesn't immediately pay for itself, printing only one thing a week. It takes a little more than 2 years on the low cost side. On the high cost side, it pays for itself immediately. And then you're starting to talk about not insignificant profit going to the consumer. So this is Emily with the printers, and we actually ended up using these later for this school. We have a giant husky dog as our mascot, so there's a big statue of it on the thing, and the alumni wanted to start having them. And so what we did is we sent a student out, took a bunch of pictures of the dog, turned that into a three-dimensional object, and now it's printable, and so all the VIP alumni from Michigan Tech have those little dogs that were printed on those printers sitting on their desk. The ROI for this is more than 100% no matter what assumption you make after 5 years. So from a consumer standpoint, even paying more for what I would consider one of the more expensive or higher end open source 3D printers on the market makes sense. If you consider the high price, the more closely equivalent, where you're customizing, where you're making something that you really want, pays for itself in under 6 months, printing out one thing a week, and has a 986% return on investment, which is probably better than everybody in this room is making on the stock market. If that's not true and you're doing better than that, we need to talk after this lecture. But that's, again, possibly picking, very high-end things. So, for example, in the study, one of the students wanted an orthotic implant or insole insert. If any of you are using orthotics, they're extremely egregiously expensive. They go for $500, $600 a piece. So you could justify the cost of the printer just printing out one pair for your shoes, and then maybe do your running shoes, and now you're gravy. What happens if we talk about things that are not expensive? In fact, toys are meant specifically not to be expensive. They are mass manufactured, and they're made in plastic.